Okay, I hope you're fine. We are continuing with mole concept and related calculation. We discussed in lesson 1 about mole as a unit of measurement, and also we discussed about lesson 2, applications of mole concept, especially converting mass of a substance to moles. And this in lesson 3, we are going to discuss application of mole concept, especially in converting volume of a gas to moles. So, before going further, we need first to understand the relationship between volume of a given gas and mole. Now, as you can see here, the relationship between volume of a given gas and moles is that number of mole equals to volume of a given substance in decimeter cubic. A volume should be in decimeter cubic divided by molar volume. And here we have a molar volume. So even molar volume is given in decimeter cubic. Decimeter cubic per mole. Here is decimeter cubic per mole. Now, we say number of mole equals to volume of a given substance divided by gram molecular volume. Now, before going further, we need first to understand what does it mean by the term molar volume. We say molar volume is nothing but only a volume of 1 mole of a substance. So a volume of 1 mole of a substance, that is molar volume. And here we have a molar volume. By definition, we say molar volume is the volume of 1 mole of a substance, is a volume of 1 mole of a substance. Especially here we are talking about volume of gases, or sometimes can be liquid. So a volume of 1 mole of a substance, that is a molar volume. Now, sometimes it is called gram molecular volume, which is noted by letter GMV, gram molecular volume. Okay, as you can see, experimentally it shows that 1 mole of a gas is equal to 22.4 decimeter cubic. And therefore, this gram molecular volume is equal to 22.4 decimeter cubic. So experimentally, it shows that 1 mole of a gas of a substance is equal to 22.4 decimeter cubic. So when we are talking about molar volume, we mean 22.4 decimeter cubic. That is a molar volume. Hence, a molar volume, or GMV, is equal to 22.4 decimeter cubic. This should be remarkable and it should be understood. Students, note this concept that 1 mole equals to 22.4 decimeter cubic, or a molar volume of a gas, that means 22.4 decimeter cubic. Now, there was a scientist, an Italian scientist known as Mr. Amedeo Avogadro. Especially, you have listened to this name. Amedeo Avogadro was a scientist who dealt with mathematics and physics. So, he was specifically dealing with mathematics and physics. He was the first person to determine the mass of particles, especially small particles. He described that a mass of an electron through his experiment, that because we are not interested in physics, this is chemistry. Here now, we have another laws that introduced by Mr. Avogadro according to his experiment. Avogadro have done an experiment which show that by measuring equal volume of all gases at a standard temperature and pressure, he found that there are equal number of particles. So, in chemistry, we have Avogadro's law relating to molecular volume. Avogadro's law states that equal volume of all gases measured at standard temperature and pressure contain the same number of particles. Equal volume of all gases measured at standard temperature and pressure contain the same number of particles. Very simple. And because in this session we're going to discuss how can we convert volume of a given gas to moles, it is simple. Let's see this example here. We have an example. Calculate moles in each of the following. You have been given 11.2 decimeter cubic of carbon dioxide. Remember, this carbon dioxide is a gas. And B, you may be required to calculate number of moles if you are given, let's say, 7.2 decimeter cubic of a can be as ammonia gas. Ammonia solution. Now, the question is to calculate moles, amount of a substance. Calculate number of moles given volume of gases. In A, we have 11.2 decimeter cubic of carbon dioxide. Now, first of all, we need to know the relationship between moles and volume. We know that number of mole equals to volume divided by molar volume. Number of mole equals to volume, but volume should be decimeter cubic divided by molar volume, which is in decimeter cubic per mole. Now, we have been given A. In A, we have volume of carbon dioxide. Volume of carbon dioxide gas, which is equal to 11.2 decimeter cubic. But automatically here, because we have not been given the molar volume, the molar volume is known. Therefore, we know that we have molar volume, which is 22.4 decimeter cubic. Now, what is required? Required number of moles. How many moles? Now, we say number of moles equals to volume in decimeter cubic, that is 11.2 divided by molar volume. Divided here, we are getting 0.5 moles. Therefore, in 11.2 decimeter cubic of carbon dioxide gas, there are 0.5 moles. In 11.2 decimeter cubic of carbon dioxide, there is 0.5 moles. Underline your answer. Simple. Very simple calculation. The first to understand is a formula that number of mole equals to volume divided by molar volume, but remember volume should be in decimeter cubic. So, note here. B. We are going to calculate number of moles. In B, you have been given that volume of ammonia, which is equal to 67.2 decimeter cubic. But also we have molar volume, which is 22.4 decimeter cubic. Required to calculate number of moles. And from number of moles equals to volume in decimeter cubic, that is 67.2. You will divide by 22 this one is decimeter cubic per mole. When you divide here, we are going to get 3. It is 3 moles. Remember, this as a unit is very essential because here we have decimeter cubic. We divide by decimeter cubic divided by mole. That means decimeter cubic times moles divided by decimeter cubic. So decimeter cubic and decimeter cubic is being cancelled, and here we are going to remain with mole. That's why our answer here is in mole. Therefore, there are 3 moles of ammonium ion in 67.2 decimeter cubic. Simple. Note. 1 decimeter cubic equals to 1 liter. 1 decimeter cubic equals to 1 liter. And also, 1 liter equals to 1,000 milliliter. And 1 milliliter equals to 1 centimeter cubic. Remember, 1 milliliter equals to 1 centimeter cubic. 1 decimeter cubic equals to 1 liter. If 1 liter equals to 1,000 milliliter, that means 1 liter equals to 1,000 centimeter cubic. Therefore, 1 decimeter cubic equals to 1,000 centimeter cubic. 1 decimeter cubic So I have been in box, making this one in a box that 1 decimeter cubic equals to 1,000 centimeter cubic. Sometimes you may be given volume in centimeter cubic. You need to change it into decimeter cubic. And now if the volume has been given in liter, no problem. 1 liter equals to 1 decimeter cubic. Therefore, conversion is nothing, just converting the unit. Because we know when we are writing this volume, we should write volume in decimeter cubic. Therefore, if you have been given milliliter,